So excuse me, I'm going to have another try at these problems when I had a meltdown on Friday. I still got the smoke going on, boy. Just been feeling a little ill all weekend, but I imagine I'm probably not the only one. So, as I said, draw a picture, label what you can. I changed this. I believe it's different than class. I'm making this 0 and this the height of the bridge, and then there's some place where the rock goes up and then it comes back down. So it starts where I'm going to call anything that has something to do with the bridge, I'm going to subscript with B or BR, and then it's going to come back down past the bridge and then continue on. So, right, so you see V bridge and then V0. We don't know what it is, but we know that it's going up, so it's positive. And we also know that the V0 up to the peak, and this is going to be negative V0, and I'm also going to call it V bridge. And we also know that at the top it's going to be 0. So these are things that aren't given to us explicitly, but we can infer. And the other thing we can infer is that it says total time to go up and back down, so that means it took 3 seconds to go up to the peak, and then it'll take 3 seconds to come back to bridge, and then 3 seconds back to bridge. And of course, since it's gravity, it's always minus 9.8. Now, I have said it before, and you can, in an exam, you can use 10.0 meters per second squared. It's just mastering. If you don't use 9.8, mastering will tell you your answer is wrong. Okay, so I look at this, and what equation am I going to use? And so my first inclination is to figure out how high it goes. And one of the reasons I want to do that is that it wants to know what's the speed at the bottom, how high. And I'm just so used to using these two guys, but we'll take a look at these. And so and then I say when I want to get the speed at the bottom, so first I would get how high, and then 2, I would get the time to drop from the peak to ground. And then once I had that time, then I could count. Once I know t from the peak to the ground. If I knew t from the top of the bridge to ground, same thing. But if I go from t from the peak to the ground, then I can use t to get the velocity at the bottom. Because then I would use equation 2.8. So this is equation 2.12. And let's see, how high, what would I say? Oh yeah, I'm going to say 3 seconds. I know 3 seconds, so I'm also going to use 2.12. So we know t up, t down. You'll see in a moment. So what do we got? Oh yeah, right. So what did I did here? That's interesting. I even forgot what I did. Aha. All right. So, what I to get to find out uh, how high it goes, I first need to know how fast that it leaves from the bridge. And so I set up v at the peak, which I know will be 0. V sub 0 is what I want, and I get me a positive 29.4 meters per second. And then I can use the equation 2.12 because I know then the initial speed, and then I know the height it's at 28 meters, and then I know the acceleration, and I know the t, so then I can end up with the height of the building. I mean the height of how high it goes up. The next problem is with the building. So then I come up with 101.5 meters. And so in this case, I didn't have to do any algebra. I plug in with units. And so at the top, when it reaches the very top, after I throw it up in the air, or the person throws it up, it goes 101.5 meters, and that's amazing, right? That's a pretty fast speed. I don't think any human being can actually throw it that fast. Okay, what's next? So now, okay, I decided to try one that I haven't used before. Right? And again, I personally stick with the first two and grind it out. So what I could have done is I could have figured out how much time it took to go from the peak to the ground. And if you recall, that's what I said here. But I'm going to short circuit that process by doing this. Let's see, where is it? Yep. So I'm going to try using 2.13. What I did is I scratched that out, the original technique, and I'll show you that in a minute. And then, I could see, it was tickling in the back of my mind that I could skip these steps. And that's what these two last equations are about. Somebody has combined 2.1, 2.8, and 2.12 in two different ways. One is to get rid of t, and let's see, this one here, oh yeah, it gets rid of the acceleration. But, in gravity problems, you always know the acceleration. Okay, so we plug in numbers. We know that let's see, V on the ground, that's what we're trying to find out when it just hits. When it's at the peak, we know it's 0, which is useful. We're calling the ground 0. The peak is 101.5. And notice there's a square term there. So the interesting thing is that we have a minus times a minus, and that's positive. And that's a good thing, because if it wasn't, we wouldn't be able to take the square root. And notice this is what my calculator gave me, but the best thing to do when it comes to sig figs is to use scientific notation. And I usually keep it with 2 decimal places, and you can always tell your calculator to what's the 3rd decimal place if you need 4 sig figs. It's very rarely that I know of in physics 2100 where you need 4. So then when I square root of it, take the square root of it, I get 4.46. Excuse me. And it says, oh, same as before. Well, that's because I haven't shown you the long form just yet. So just hold on a minute there. So the thing we have to keep in mind now when we use this this equation 2.13, we don't have a sign anymore. So there's 2 things. You have to be really, really careful when you plug in the signs into any of these equations, but most especially this equation. And then you have to realize that you need the diagram so that you can tell the reader, the grader, or the people that it's in the downwards direction, or you could put minus sign there. Okay. So I am going to stop this for a minute or pause it. Let's see. So as I said, what I can do is I can use the, I can never remember the numbers, but the one magic equation here, and the reason when I wanted to get y peak, because I knew that the velocity at the peak was 0, and that's good, so I can avoid the quadratic equation in this case, and I can end up getting a time, and that's funny. Oh yeah, it's right here. I just kind of crowded it together. So I got the t, and this is from the peak to the ground. So get t, peak to ground. And so I got the 4.55 seconds. And when I put it in there, I got negative 44.6, which is what I got before. And that's just, in this case, it's in scientific notation. And of course, we must remember that, well, if I say it's down, that's okay, but you might want to put this here just to be absolutely certain.